So, hello guys, today we are going to solve or revise the problems of binary tree miscellaneous problem category of a SDE sheet. So how we will start is keeping it simple. We will just revise the approach and in the later live stream we will try to solve it. But before revising this and solving it, we will keep again another revision for the same so that while implementing we don't just copy and do it. So show your support by subscribing to my channel. So what the first question says, flatten binary tree to a linked list. We are given a root of binary tree, flatten it to a linked list. Linked list should use the same, okay, where the right pointer points to the next node. So this was quite interesting. I had understood the approach from Striver, then applied for mine. So the likes are also high, which means it's probably a good question. So Facebook, Amazon have also asked. So what happens is, for each node, we will keep track of if there is a left present or not. Since here left is present, we will keep track of this and go to what are you doing, man? Okay. So after getting the leftmost, what we will do is for the leftmost we will guide to the rightmost node. So this is our left right. So what we will do is current dot right equals to this and leftmost right equals to current dot right. So the new node formation will be 1, 2, 4, 5, 6, and here 2 will have 3. So again here this will be our current, this will be our left, rightmost is null, so it means rightmost is this itself. So current dot right left right is this. So current dot left right is equals to this left and left right dot right equals to current dot right. So first we have to do current dot left right dot right equals to current dot right, then update the current dot right to left. So this was quite simple solution. Uh, very fourth thing, pointer minimize. So previously while I was following Striver's thing, there was one slight problem. Currently, I'm not able to understand, but remember, but this is the core logic over here. Yes, so the time complexity, let's understand. We are most probably for this node, then this node, then this node, and this node, right, this node, right. All right, we'll keep on going. So O of n would be our time complexity. Space complexity, if we see, I think so it will be constant because we are using this and yeah, this 2. So O of 3 which is equals to O of 1. Does slash turn binary tree to linked list? Complexity analysis. O of 2n. O of 1. Yes. For establishing temporarily and once reverting it. Okay. In worst case 2n. Because for every if there is a right, we are iterating all, and then again we are iterating them again when they have become part of the right. So around 2n, this is done. Find the median of data string. This is also quite simple one. When I was implementing, find the median of data string. If the size is even, there is no middle value. The median is middle value of 2. Middle of the two, average means. So first we'll add this one, then we will add 2. The median would be 0.5 since the middle is, what we say, even length, or yes, even length. Then this two, how is this happening is we are using two priority queues. Priority queue, first one is of type max heap, second is type min heap. So or let's take a bigger example. uh, they don't have any bigger example, so what we are going to do is, uh, guys, why you are coming here? I asked you for earlier only. So what's happening is, in the first we'll add the element in the mean. If there is a discrepancy greater than 2, it means that there is imbalance and we have to shift. So 1 is added over here. Then what is the next element? There is 2. So here it is. But now there is a discrepancy. Here the length is of 2, here the length is of 0. So since discrepancy is of greater than or equals to 2, we will shift one element. Let's keep it equals to 2. So we will shift one element from here. So here there will be 1, 2 will come out over here. So the max value comes out over here. After which we do is 3, add 3. Since the discrepancy is of 1, it's allowed. So uh, now how we will return the median, you might ask. So array means priority queue, which one has the higher length, its first element will be popped out. So this is a mean heap, so 2 will pop out. If there was again we say 0 over here, so now since it is equal, we will take average of the first two pops. So the space complexity, let me first get the code out. Let first the space complexity or first the code. Let's see the code first. Then calculation of space complexity will be easier. See max and min heap as I told, for by default it is a min heap, minimum values, so highest priority gets out. This is a max heap default. So this is hiding. Why is not shifting, man? Let's keep it up. So by default adding, if is not empty and the peak is greater, then we will add. Okay, so if size is also different, so this is one condition that I have to tell you. So what happens is, after addition in the, if here it is 3, so by default we are adding it in the max heap. So what can happen is sometimes 3, since 3 is greater than 2, we have to transfer it over here because we have to order it in such a way. So this was the logic. But now if here there was not a 1, so again there is discrepancy. So this again, if statement helps to push 2 back to the max heap of the free, means the max heap from the minute. So this was also quite easy. We have tackled it. Let's move on. Uh, which it is kth largest element in a string. So what the question states is, design a class to find the kth largest element in a string. Note that it is the kth largest element in sorted order, not the kth distinct element. Kth largest element in the sorted order. Yes. So this is also priority. I like this question also. What is happening is, we want the kth largest element, so we can keep a max heap of what size? Max heap of size they have provided. So k is the size. Where is k over here? So k is here 3. So first we will keep all of these values 4, 6, 4, 5, 8. So max heap, no? So this is our kth largest element till here. Hmm, kth largest element. Also kth largest. So the kth largest till now it is 3. So we don't have a problem. Since now we will add 2. Since 2 is not the max value, okay. Should we keep a min heap then? These kids shouting distracted me. So what our goal is, 4, 5, 8, add 3. Okay, so amongst this, the max is largest, so the max 3 should come over here. So we will not keep a max heap, we will keep a min heap. Why? So the lowest value bubbles up at the top and we will pop it out for the newer value if it is greater than that. If it is not, we will not pop it, we will keep it as it is. So let's do an iteration over here. Uh, First we will add 4, then there is 5. So our max heap 5 will come at the top, but now there is 8. So what operation should we do? Array, mean heap it is, no? So 5 will stay below, not over here. So next is 8. So 8 will come over here. Then 2. So since it is mean heap, 2 will come over here. 4 and 5. What is next is happening is this is our new mean heap. Now for the add operation, the problem out here is we can't keep means the size should always be equals to k, but now it is not equals to k. So what happens is we will pop out the lowest value. Guys, sorry I got distracted again, but you understood the thing. Let's we should not have put 2 in the first place only because it is lower than the lowest value in the heap. So we will not do. So this is our maintained heap till now for the kth largest operation. Now in the add operation, what happens is, let's undo this, undo, yeah, eraser, we don't want this, we don't want all of this as well. So among this, what we will do is 3. So since 3 is again smaller, so we will just return this. Then next is 5. So now we will pop out the thing which is 4. Yes, we are right. Then add it. After the addition, we will return the mean heap value at the top. So 3 is done, 5 is done. Now 10. So what happens is we will use the eraser. Pop, oh no, let's use that one. Remove this and this. So now 8 remains and 10 is added. Again the thing is 5. Now we will do again 9. So what happens is eraser comes out. We will cut this out and put it at the top. 8 comes at the top because we have popped 5 to add our new value of 9. Again 4 will come, but since it is less than the mean lowest value, we will just keep return the mean heap top. So that was it. Let's look at the code. So K5 we will add, and since addition here, add is here the function. If size k of s less than k, offer. If peak less than n, okay. Else we will not do any operation. In what is the else over here? That the value n is smaller than the top, and then we will just do the return. So I spend more time on it, but it's okay. So save the code, don't cancel. So what is this distinct numbers in a window? Where is my Brave browser? You are given an integer. My friend is calling me. हेलो. हाँ बोल. हाँ. କିନ୍ତୁ એમાં પછી પ્રોજેક્ટ હશે તો બધા મતલબ યાદ છે એન્ક્રિપ્શન એલ્ગોરિધમ ના બધા ઈબીએસ માં હતું ને ઈબીએસ માં વાળા હતા એમાં તો નવા એલ્ગોરિધમ. હેલો. વિસ્મય તું કયું બોલે ઇન્ફોર્મેશન સિક્યોરિટી ઇન્ફ્રાસ્ટ્રક્ચર સિક્યોરિટી કેમ કે ઇન્ફોર્મેશન સિક્યોરિટીમાં થિયરી છે કાંઈ પણ સિલેક્ટ કરી લેવાનું. હું શું કહું છું આપણે અડધો કલાક પછી વાત કરીએ. હેલો હેલો તમે લોકો રિટાયર કરી હું થોડો અડધો કલાક પછી કરી દઈશું. હા. ચાલો. Sorry guys, uh, there- for our new start of SEM, there was discussion for optional subject selection. So that thing has been done. So this is also quite a simple question. What we are doing for the size of you are given an array and an integer b. So yes, return the count of distinct. So size of b is 3. So for the three elements, how many distincts are there? So here only two, 1 and 2 are distinct. We, let's see the output 2. So the distinct characters that are 1 and 2, it can be duplicated, it is okay. But 1 and 2 is distinct. We don't have to count the repeating ones. So after that, with this 3, then this, after this 3, let's draw it only. This is the first 3, then first 3, then the second 3, then the other 3. So 3, 3, 3. So how we will loop it out is n minus n is the length minus b. Okay, so what happens is all the elements, so our array will be of size n minus b, and we will keep count of all the elements. So what can happen is we can use for loop. So for loop of size b from 0 to b, then for loop from of size b again from 1 to b plus 1. So what can happen, the time complexity is O of n into b. This is our time comp. Other solution is to keep a hash map. That is little bit confusing, but not that much. What we can do is 1 is occurring 2 times, 2 is occurring 1 time. So we will have to keep two indexes. One index over here I, and second that iterates all to the all elements. So till here j has come. Yes. So after which what happens is uh, 1 to 1, that is done. After which the position slide will go ahead. Now 1 is not part of the window. So we will remove that j, decrement this I element. So this will cut down to 1, and we will add 3 again. Yes, that is it. What happens next? Is the timer running for this thing? I don't want, man. Stop this. 33 minutes or 33 hours. How can we stop it? Yeah, we will stop it later on. So we have reduced this. Now we will move ahead. J comes over here. So index I comes over here. So now what happens is we will remove 2. It becomes 0. So we can do, what we can do is we can remove this as a whole. Why? Because the size of the map gives us how many distinct elements are there. So we, if our 0 is removed, so what happens is for the size, let's change the color, pink, purple. So now this is our thing. So now our size for means the window, our distinct elements are again 3, but here 2 is not calculated. So this is also quite easy. Ish, have to stop the timer. What's happening here? Everything is being distraction and distraction today. Why I'm saying this? Because in the morning a bird was hanging on me, so we called the fire rescue team. After that, I did some management of my goals, clear out my goals. Then I worked on managing my shelf of clothes. That took some time. Now, currently, I'm doing this. So many people are coming in and out. So, timer, I've not shut down the timer. Why am I forgetting this? So, this was our thing. We didn't need help of driver. Mm, when will this timer get stopped? Let's just submit it so that the timer shut down. So, what I was saying is, let's do the brute force. No, this is also easy. New hash map. What we will int array answer is equals to new int array a dot length minus b for int I equals to 0. Let's okay. So the j pointer which was saying that it will iterate the whole thing a dot length j plus plus. So this is done. After which we do is what we do is j j j j j j j j if map dot size is less than b. No, what I'm saying, what is this logic? If j is less than b, so we will keep on adding map dot put what we will put mm, a of j map dot get or default a if a of j is already present. If not present, we will keep it 0 and add 1. This is done. Then else if j is what we will do is answer int I equals to 0. Answer of I equals to map dot size. After which we do is now in the next step I is not needed. So map dot put map dot put what we will put map dot get for a of I plus plus we will map dot get or default. Let's not do I plus plus over here. Map dot get or default. map.get it is only map.get a of I, after which we will do -1. If map.get a of I equals to 0, map.remove a of I, then we will do I plus plus return answer. Trial case. So 0, answer of 0 is equals to map dot size. Yes, map dot. Okay. So, after removing, we have to add the next value. So the logic was correct, but if j minus I equals to b, okay, so then what's the problem? Okay, so we are returning answer. Let me ask ChatGPT. ChatGPT, So let's hide our thing. What is error? One, two, three. This is correct. So now what the problem might be, condition to update. So next, case largest element in an array. You are given and return. You are given an array and an integer key. Return the kth largest element in array. It's sorted order, not a distinct element. Kth largest from end k. Okay. So after sorting, what would the values be? 1, 2, 3, 4, 5, 6. So how did they achieve it? Most probably by using a priority queue of size 2. So it it will be a mean heap. So 3 will be there, then 2 and 3 will happen, then 1 is what smaller, so we will not take it, then 5 will come in, so 3 and 5, then what, 6 will come in, then 5 and 6, then what, 4. So after the operation we will just pop the top out. Was it that simple? Yes, it was. Right, Q. Yes, it is that simple. Let's fill the last question, then we can wrap it up. Flood fill. So what we can do out here? You are given an image represented by m into n, where image represents. You are also given integer, three integer source S, R, S, C, and color. You have to perform flood fill or image starting from. Okay. So if 1 means we can color, 0 means we cannot. So there are only if it is the same color as intended, we will just return it. So that was our edge case. If same color as intended, I don't know spelling. I can't see the spelling, but it's probably right. Okay, so now this is done. From source, we can do is breadth first search or depth first search. So if you do breadth first search, this is added into view, this is added into view, this can't be added, this can't be added because it is unsafe. We will keep on condition for unsafe. So after that, we will update the color. So currently our own node is also of different color, so we will update it that first. Then update. So the start of the queue would be something like queue before the loop queue dot add srst. So this could be a pair. Then we can then what we can do is while not empty, while लूप के अंदर हम लोग पॉप करेंगे, पॉप ऑपरेशन fill with color for that source, and then check for neighbor. I don't know the spelling. That was it. Let's take the pointer and check for the code. Yes, Q is used. Direction is also there. Is safe. Yes, it is the same. Here we don't need visited because we just have to start from here. So we don't have to visit all. Yes, that is also true. Or in is safe also if the thing is if equals to color. Value is our color. Is safe. Value. What is value? Well. Where is the well variable? Well. Okay. Well is equals to, okay, so all the corresponding values. So one, so all the ones will get filled. Correct. So one, so we have to fill q dot offer source color. That was easy. Time complexity, if we see breadth first search, it takes what? Breadth first search, what time would it take? Let's think, because I don't remember the time complexity. So how the time complexity goes? In the worst case, all the nodes will be taken. So how many branches are there? BFS. Give me time complexity. O of n for the thing, O of 2e, twice the edge. So blur fill also will see. it's not given. Let's check in our what we call this notes, online notes. Easy. Let's not return the time complexity. Control E, sorry, Control F, flood fill. It's quite old. 24 DSA2 book, DSA2, DSA2, DSA2. Yes, this is my second notebook filled with DSA. Minimum height of a tree. The DP is coming out here. Topological sort. After that, detect cycle in undirected graph. Kahan's algorithm is topological sort. Okay, both to same people. This is 3. So previously 1, what is it? 20. Flood failure. Brute force. So I have not written time complexity over there also. So where is DFS? DFS. Low in binary search tree. Time complexity of depth first search. Let's see time complex DFS. What is so around this time it will take O n plus e. मतलब v plus e it is. Yes, v plus e is over here. V plus e over here as well. So how? Let's see how. Breath O n n n n. So 4, and from here 4 directions. Here 4 directions. So 4 raised to m into n could be the worst case. Let's ask ChatGPT what is time complexity of this problem. Let's fill main loop for, so it will move check every m into n thing, means so it will check all the elements in the grid. So not 4 raised to n because it's not doing visited for all. Hmm. Let's keep this time complexity thing. Till then, bye bye. I hope you liked, but I had done some time pass in the between thing, but it's okay. Chalo. Till then, bye bye.